Have you ever wondered, why is the night sky dark? This seemingly simple question actually puzzled astronomers for centuries, and the truth behind it holds the key to understanding the very nature of the universe. If you think about it deeply, you'll realize that the darkness of the night sky is far from obvious. After all, our universe contains trillions upon trillions of stars. They are scattered almost evenly in every direction of the cosmos. The light they emit radiates outward into space. Logically, the night sky should be filled with this light, so much so that there would be no difference between day and night. But in reality, this isn't the case. So where does the problem lie? Imagine yourself standing in the middle of a vast forest. Suppose this forest stretches so far that it seems endless. Now, if you shoot an arrow in any direction, no matter how you try to avoid it, it will inevitably strike a tree. And let's ignore gravity here. Otherwise the arrow might hit the ground first. This simple thought experiment reveals something. When you are inside an infinite forest, every line of sight is blocked by trees. Now let's extend this to the universe. If the cosmos were infinite, filled with countless stars distributed in every direction, then logically, every point in the sky should be covered by a star. Just like in the forest, stars should form an unbroken wall of light. Every line of sight would end on a glowing star. That means, when we look up at the night sky, or even at deep-field telescope images, those dark gaps shouldn't exist. Instead, the entire sky should blaze as brightly as the surface of the sun. So why isn't it like that? Back in the 16th century, astronomer Thomas Digges suggested that there was no mystery here. He argued that distant stars are simply too faint to light up the sky. It sounds reasonable. After all, stars appear dimmer the farther away they are. In fact, their brightness decreases with the square of the distance. A star twice as far looks 4 times dimmer, 3 times farther, 9 times dimmer, and so on. But in the 18th century, Swiss astronomer Jean-Philippe de Tissot pointed out a flaw. While stars get dimmer with distance, the number of stars also increases with distance, because the volume of space grows. So the problem wasn't solved. He used an abstract geometric idea called spherical shells to explain this. Imagine stars arranged in concentric shells around Earth, like the layers of an onion, extending infinitely. If the star's brightness and density were roughly uniform, then each shell farther out would contain more stars. And while those stars would appear dimmer, their larger numbers would compensate exactly for their faintness. Mathematically, each shell should contribute the same amount of light to the sky. Stack up infinite shells, and the sky should become infinitely bright. Clearly, distance dimming alone cannot explain the dark night sky. If the universe were truly infinite, our sky should glow like the sun. De Tissot's work revived an old idea from Kepler in the 17th century, that the universe might be finite in size. But modern astronomy shows no clear edge to the observable universe. In 1823, German astronomer Heinrich Olbers took on the question seriously. The paradox later became known as Olbers' paradox. He dismissed the "stars are too faint" explanation and proposed another. Perhaps interstellar gas and dust blocked starlight. But here's the catch. Dust and gas absorb light, but then re-emit it as heat radiation. Over infinite time, that radiation would still fill the sky. So the darkness had to be caused by something else. And surprisingly, the first person to propose the right answer wasn't an astronomer. It wasn't even a scientist. It was the poet Edgar Allan Poe. In 1848, a year before his death, Poe published his prose poem Eureka. In it, he wrote that the universe simply wasn't old enough. Even if space were infinite, the light from the most distant regions hadn't yet had time to reach Earth. He was right. Today we know the universe began with the Big Bang, about 13.8 billion years ago. From an astronomical perspective, that's still very young. Light from stars beyond 13.8 billion light-years hasn't had time to arrive. So the darkness of the night sky reveals something profound. We can only see a fraction of the universe. Even more, the expansion of the universe stretches light waves, a phenomenon called redshift. Over billions of years, energetic ultraviolet light shifts down to infrared by the time it reaches us, making the night sky even dimmer. And because the universe's expansion is accelerating, galaxies are receding faster and faster, some so fast their light will never reach us at all. Beyond a certain boundary, the cosmic event horizon, those stars and galaxies will forever remain invisible. This guarantees that the night sky will always stay dark. In fact, in the far future, as more galaxies vanish beyond the horizon, the universe will look even darker. Future astronomers may see only the stars of the Milky Way, with the rest of the cosmos erased from view. But here's the astonishing part. This profound truth doesn't require advanced telescopes. Anyone can see the evidence with their own eyes. Every time we look up at the dark night sky, we are witnessing direct proof of the universe's beginning.